We learn science through various stages, and it's good to learn in bits and pieces, but sometimes things are so generalized that we consider them as facts and get attached to that partial truth for the rest of life, and we realize that we were taught wrong only when there is a sudden eureka moment. For example, the sun rises in the east and sets in the west is a universal truth, and no one can deny that this is an empirical truth, not the absolute truth. Convictions like this are very common during our duration in school. While they are not the complete truth, we also cannot claim them as false. They help us to grasp the absolute reality. Before understanding the phenomenon of rotation of the earth that leads to the occurrence of day and night, firstly we have to make sense of the rising and setting of the sun. Thus we can call this not a false theory but a partial truth. We have learned many partial truths like this, and some remain still with us even when we are studying higher courses. Let's look up such partial truths that are very common. My name is Siddharth and you're watching The World of Science. The planetary model of an atom. We have seen images of an atom with a positive nucleus in the center and negative electrons moving around in a well-defined orbit, like the planets move around the sun. This is Rutherford's planetary model, which was later corrected by Bohr's model while putting the similar structure, but electrons were allowed to move only in a particular orbit with a definite energy level. We have to note here that when this model was proposed, neither the neutron was discovered nor the uncertainty principle was proposed by Heisenberg. In reality, electrons do not move in a well-defined orbit because they cannot be defined in a particular place at a particular time with certainty. The accepted model is called the electron cloud model, in which electrons exist around the nucleus in a probability cloud where an electron is most likely to be found. Electrons can be understood to exist at multiple places at a time since they are represented by a mathematical wave function, and only upon measurement that electron can occupy a certain position. Thus, before measurement, electrons could be found over a definite region, and that region is called electron cloud or atomic orbitals that exist in various shapes. Orbitals are named as S, P, D, and F. S orbital looks like a circle, while P orbital looks like a dumbbell-shaped region. Each orbital can be occupied by one or two electrons. The model was proposed by Schrödinger and Heisenberg and is most widely accepted. States of matter. We have been taught only three states or phases of matter, that is solids, liquids, and gases. Later on, we are also taught of a fourth state known as plasma. All the stars and the intergalactic matter are formed of plasma. The states of matter are generally classified based on energy states. In low energy states, we also have many intermediate states and extreme condition states such as Bose-Einstein condensate. Bose-Einstein condensate are those bosons that occupy the lowest energy state and merge into a single wave or particle when the temperature is reduced near to absolute zero. Pauli exclusion law does not hold for bosons, thus many bosons can exist at the same energy level at the same time and form a single entity as if they are one single particle. Apart from them, there are degenerate matter types such as electron degenerate matter found in the white dwarfs and neutron degenerate matter found in a neutron star. They are matters found in the extreme state when a star is supported by its degeneracy pressure against the gravitational collapse. Rydberg polaron, quark-gluon plasma, fermionic condensate are other examples of different states of matter. No gravity in space. Well, that is why astronauts keep floating inside the International Space Station, but that is not the case. While gravity does tend to go weaker as we move away from the planet, but the height at which ISS is placed, Earth's gravity is still about 90% of gravity on land. So why do we feel weightlessness there? The answer is they are in constant free fall. Gravity acts with the same acceleration on different bodies regardless of their mass, but on Earth, due to air resistance, we do not feel that way. But space is a vacuum, and thus you, the spacecraft, and all the instruments will fall at the same acceleration and everyone will appear to be floating around. On the other hand, the station is moving at a huge speed of 7.6 kilometers per second, which keeps the ISS in orbit. It keeps falling towards the Earth, but this speed maintains the ISS to match the curve around the Earth. Gravity is a force. Gravity is one of the four fundamental forces, and this is again a universal truth. Even in higher education, we study the same thing because no one can deny that. But general relativity challenges this notion. It does not deny gravity, but argues that this force is a perception we get of the bodies following a path in a curved space-time around a body. Now again, understanding the Newtonian concept of universal gravitation is a pathway to understanding the bigger picture. An object falls because it is following the geodesic formed by the warping of space-time due to the presence of a mass-energy tensor, in this case our Earth. The temporal dimension is warped near the surface of the Earth, thus time moves slower near a gravitational potential. Farther from the pull of Earth's gravity, clocks tick faster. Thus the fall of an object is the movement of an object from a faster time to a slower time. The body moves simultaneously in space and time. As the body moves faster in time, slower will be the speed in spatial dimension and vice versa. Thus, when a body is falling from the top of the building, that is faster time to ground, that is slower time, it changes its speed from low speed to high speed. As the speed in temporal dimension reduces, speed in spatial dimension will increase, and this change in speed is same as the calculated value of gravitational acceleration, that is 9.8 meter per second squared. Sixth sense. We have 5 sensory organs, that is eyes, ears, nose, tongue and skin, from which we can sense light, sound, smell, taste and touch respectively, but scientists and philosophers have argued for a long time that there may be a sixth sense in the body. During genetic and neurological studies on mice, some researchers proposed that there may be a sixth sense in the body and our genetics may have played an important role in their development. This sixth sense is called proprioception, which deals with how our brain understands and makes sense of the body in surrounding space. This system includes the sense of movement and positioning of the limbs and muscles of our body. Proprioception is acted upon by mechanosensory neurons present in the muscles, tendons and joints of the body. Mechanosensation is a property of the body to sense the force acting on it. Scientists found that there is a particular gene inside the body called piezo-type mechanosensitive ion channel component 2, or simply piezo2, that causes the cell to produce these mechanosensitive proteins responsible for providing a sixth sense which enables us to do work without even being conscious of it, like walking without being conscious where your foot is taking place in the night, or climbing stairs without looking, etc. The list is long. Like blue blood in veins is not due to deoxygenation but a reflection of low penetrating blue light by the surface of the skin. And chameleons do not change color to scare us but to maintain their body temperature. Different colors absorb different amounts of heat. Black absorbs more heat while pale reflects more heat. Colors can also be used to signal their mating partners. When we understand the real reason behind the phenomenon, we get to know that maybe we could not understand these explanations while we were still young. Maybe teaching partial truths was to prepare us so that we can understand the real, tougher explanation. The important thing is that we should keep asking questions and try to find the complete answers. And in this quest, we will help you by making such videos to make science easier and more fun than it has ever been. Do you know anything else that schools have taught us wrong? Let us know in the comments. If you found this video interesting, please leave a thumbs up and share it with your friends. Check out our new Hindi channel from the description below. Do follow us on Instagram for daily quality content that'll make you fall in love with science. Comment down the topics that you want us to cover in our next videos. Make sure you subscribe to the World of Science. Until next time, stay scientific.